All right, 3.2, exponential and logistic modeling. So the one and only thing of notes is the exponential population model.
Whoa, why just go to switch to Word? I'm doing appreciate.
So if a population P is changing at a constant percentage rate R each year, then P of T is equal to P sub 0 of 1 plus R raised to the T, where P sub 0 is the initial population R is expressed as a decimal, and T is time in years. All right, so we're going to look at some examples. We're going to tell whether the function is exponential, growth, or decay, and then find the constant percentage rate of growth or decay. So, problem number 2 is P of T is equal to 4.3 times 1.018 raised to the T. So my initial, okay, P sub 0 is equal to 4.3. Okay, just following the formula, okay, here. So then this middle part, this 1 plus R, is equal to 1.018. We're finding R, so we need to get R by itself, so we're going to subtract 1, so R is equal to 0.018. This is greater than 0, therefore, okay, that's what the 3 dots that look like a triangle mean. It's an exponential growth function with a growth rate of 1.8%. Okay, so you just move the decimal place over to make it a percentage.
I thought for it to be a growth function, it had to be greater than 1.
This is different.
Oh. And that is why we didn't do this yesterday. I did it instead.
Because you've got the number in front of it, it's also being multiplied. Which is why it's not just that. All right, another one.
Wait, what do the 3 dots mean again?
Therefore.
Okay.
Number 6, g of t is equal to 43 times 0.05 raised to the t. So what's my initial p sub 0? 43. So then 1 plus r is equal to 0.05. Need to get r by itself, so I subtract 1, and what does that give me?
Negative.
Yep, negative 0.95. That value is less than 0. Therefore, it's an exponential decay function. With a decay rate of 95%.
Oh, okay, this is not bad. I was like so confused at first because I didn't know what the dots meant, and then I was like, where the heck did those numbers come from?
All right, the next ones, it says determine the exponential, I can't talk, the exponential function that satisfies the given conditions. So, you have something like number 8, the initial value is 52. We're told that it's increasing at a rate of 2.3% per day.
But the same thing, it's just give it to you differently.
So now we're starting with this information. We're starting with the information that I previously did in blue. We want to get to what I had previously written in, or what was previously written in black.
Okay.
So basically we're doing the reverse of what we just did.
Okay.
So the initial value, this p sub, or is going to be this p sub 0, okay, is the 52. It's increasing, okay, meaning what?
Growth.
Okay, it's going to be growth. So I'm going to write that over here. And then the rate of 2.3% per day, what is that as a decimal?
0.023.
0.023, okay? Now, that's not R, okay? Or, well, it is R. Let me,
It's not 1 plus r.
yes, thank you. That was what I was trying to say. It's R, it's not 1 plus R. So we'll have to also find that because we want to write it back in this formula up here underlined in blue.
Okay, well then are you just adding 1 to it?
Yep. So, R is equal to 0.023 plus 1. So then 1.023 is my 1 plus R. This, I guess technically shouldn't, this should not really say R equals because this is technically R plus 1. So anyways, there we go. So now we just write down our formula. P of t is equal to the initial value, 52, times my 1 plus r, which is going to be my 1.023 raised to the t.
Cool.
All right, let's look at another one. Number 10. The initial value is equal to 5. It's decreasing at a rate of 0.59% per week.
So it's decay. And it's 0.059. And 5 is your.
Are you sure?
Per week? Does that
You
change?
gotta move the decimal place 2 places.
Decaying, isn't it?
0.0059.
What did you say, Joelle?
Nothing.
Does it matter if it's decay or growth, like the numbers, like would it change anything on how you do it?
What do you mean?
Because if it's decreasing at a rate, isn't it decay? We already
Yeah. So basically, it's just
Negative?
It's decay, meaning this number is going to be negative, yeah.
I have a question. How do you know how far over to move the decimal?
2 decimals.
It's always 2, because it's the, yeah, because the percentage is 100, so you have to move it 2. Yep.
So isn't it just P of T? Oh, well, do you need your R plus 1? Do you have to do that every time?
Yeah, so I need to find my r plus 1. Now, keep in mind this negative sign that's on here, okay? So when you do your r plus 1, you've got to have that sign with it, or your answer will come out to be wrong.
You need a calculator?
Yeah.
It's about
So
the
your
same.
r plus 1 is negative 0.0059 plus 1. So then, to set it up, P of T equals,
5
where is it? Thank you. I was like, I can't find it.
times 0.9941. How was that not negative? Oh, never mind. Don't.
And then raise it to the T. The T is just the time. So whatever your units are for that particular problem, it's just your time for that. So it could be hours, days, weeks, months, years,
Oh, like
centuries, you know, whatever.
that's good. Pretty easy.
All right, what we're going to do is we're going to do 2 more of, I haven't taught you that stuff yet, so we may have to hold on. Okay, we're going to at least write this example down. I don't know yet if we're going to do it today or if we wait and do it tomorrow, but I'll see how long it takes to write it down. All right, so suppose a culture of 100 bacteria
Ew.
is put into a petri dish
I love petri dishes.
and the culture doubles every hour.
Ew. This is cool.
Predict when the number of bacteria will be 350,000. Taylor, what time do you have to leave? 5 after?
Technically, yeah.
Okay.
That's
I didn't know if I couldn't remember if it was 9 or if it was 9:05. That's
Well,
why I was.
honestly, I kind of just leave either one of those times depending on what work we're doing.
so.
Okay.
Don't you just divide 300?
Because if it doubles every hour, so if it 100
So you-
doubles, then it'd be 200. If 200 doubles, it's 400. So you can't just divide by.
Exactly. So at hour 0, okay. So at 0 hours, we start with 100. Okay.
And at 1 hour, it'd be 200.
At 1 hour,
And at
we
3
have
hours,
doubled,
it'd be 400.
and it's 200. And I'm going to write something over here in just a second. 2 hours, like you said, is 400. Okay. And then at 3 hours, what would it be? 800. Okay, so I'm going to write something over here, and then we're going to basically come up with a pattern for this. So, our initial value, okay, this 100 is our P sub 0. Okay, so it's going to be 100 times 2. Okay, and this is what's changing every time. So it's raised to the 1 in this case. Okay. The next one, we still have our initial 100.
100 times 2 to the squared. 2 to the squared.
Yep,
really, that's
times 2 squared. And down here it's 100 times 2 cubed. Okay, so in general, our formula for this would be 100 times 2 raised to the t, with t being in hours.
Oh, that's so cool.
Okay, so then we can actually write this. okay, down here as, we can just do a ... continuation, okay, that you could keep writing this out if you wanted to, or we can write the general formula. P of t is equal to 100 times 2 raised to the t. Okay, now it asks us predict when the number of bacteria will be 350,000, meaning when our P of t is equal to 350,000. So I'm gonna change and switch colors here. So now I replace, so here, this is my P of t value here. Okay, I realize that looks like the same color, but I promise they're different. One's blue and one's black. All right, so we're putting the 350,000 equal to 100 times 2 to the t. So I'm solving for t. I want to know how many hours it's going to take. Now, it may not be an exact number of hours, so we may have to put the decimal or whatever. So we can divide by 100, which is going to get rid of 2 of our zeros. Okay, so 3,500 is equal to 2 to the t.
Oh my gosh. Then you just divide by 2?
Nope, because this is an exponent. Now, I'm going to swap these because, and then leave a little bit of a space, because I don't know if y'all remember how to solve these. But when we want to solve, okay, an exponential, we use what to undo it? Do you remember?
I know.
We use logarithm to undo it. So we draw the L. So this is log base 2 of 3,500 is equal to t. So then on your calculators, okay, I'm going to remind you how to do this because it's obviously been a while.
Was this year, Algebra 2?
That's algebra 2. Technically,
Can you like leave alone?
yeah, technically we will actually do a section on conversions of exponentials to logs and logs to exponentials. Like in this chapter, it's just not yet. What?
The other one is just like starts off as a log, you put it in A with E.
Yep. All right, so on your calculator, you're going to click math. Then you're going to arrow up, okay? And it's going to take you to one that says, it's going to look like this. Log base, okay?
Enter.
You're going to hit enter, and then it's going to look like this. It's going to show you a log. It's going to have a little box, and then it's going to have parentheses with a box inside of it, okay? So you're putting in the little box of 2, and then you'll have to arrow over. Okay, and then in this one, you're putting the 3,500. And then you hit enter, and so that would say that t is equal to 11.77. Now, I'm okay with this. You got to put your units on there. That's in hours. The way your book wants you to do it, okay, is they want you to convert this 0.77 hours to minutes. So, to do that, okay, 0.77 times 60, because there's 60 minutes in an hour. So 0.77 times 60 is about 46 minutes. Okay, it's technically 46.2 minutes. So your official answer would be 11 hours and 46 minutes.
Cool. That's cool. I like that.
So not too bad. We'll do a few more examples with this stuff tomorrow. I don't know if y'all did anything talking about half-life with like Miss Marshall at any point, but we'll deal with some half-life stuff that comes with this and word problems and what that looks like. So